We know the importance of water for the survival of living things. We have also learnt something about different sources of water, their importance, water pollution, and water management. Water is a compound. Water is especially important as a liquid. One molecule of water is made by the combination of two atoms of hydrogen with one atom of oxygen. We all drink water every day. Have you ever thought about the taste of water? Let us try to find whether the water has any taste. Students, we all have tasted lemonade. How does it taste? It is sour and sweet in taste. How does water in which salt is added taste? It is salty. Did you notice any common characteristic of water? The taste of water changes according to the substance added in it. Lemonade tastes sweet and sour due to the lemon juice and sugar. The salt water tastes salty because of the salt added in it. Water does not have its own taste. From the above examples, we can state a property of water, that is, water is tasteless. Let us call it as property 1. Let us see another property of water, that is, water is colorless. How? That we will see now. Take 2 glasses filled with water. In glass 1, let us add some red color. What did you observe? The water in the glass has turned red. Now, in glass 2, let us add green color. What is your observation? The water in this glass has turned green. Students, did you notice that the color of water changes according to the color we add in it? So basically, water itself doesn't have its own color. So we can state that water is colorless. Let us call it as property 2. Like the above 2 properties of water, that is, tasteless and colorless, water is odorless too. The odor of the water changes according to the substance mixed in it. Let us call it as property 3, that is, water is odorless. Take water in a beaker. Can you see through the water in the beaker? Yes, we can see through the water. It means that water is transparent. These properties make water irreplaceable as a means to cleanliness. Let us learn more characteristics of water. Take 100 milliliters of water in a glass vessel. Mark the level of water. Place the vessel in the refrigerator for making ice. Do not spill the water while keeping the vessel in the refrigerator. The next day, you will see that the water has changed to ice. Note the level of ice. You will see the difference in the level of the water and ice. Level of the ice is higher than the level of water marked earlier. What does this tell us? As water changes to ice at 0 degrees Celsius, its volume increases. Let us study something more regarding the volume of water. Put a coin and a block of wood in a bucket of water. What do you see? The coin sinks to the bottom and wood floats on the water in spite of being larger than a coin. Why is this so? Whether an object will float or sink depends upon its mass and not upon its volume or size. The coin has greater mass than wooden block, so it sinks. If a coin is beaten into a sheet and if it is given a different shape, its volume increases, so it will float on water. Now, let us study the relation between volume and mass. The mass of a unit volume of a substance is called the density of the substance. So, we can express density as mass upon volume. Mass is measured in grams and volume in cubic centimeters. Hence, the unit of density is grams per cubic centimeters. 1 liter of water has a mass of 1 kilogram. Hence, the density of water is equal to 1 kilogram per 1 liter is equal to 1000 grams per 1000 cubic centimeters. Hence, density of water is equal to 1 gram per cubic centimeters. As water freezes, that is, as it changes into a solid, its volume increases. Thus, its density decreases. That is why ice floats on water. The density of water has a special characteristic. Let us learn about that. The anomalous expansion of water. Normally, as the temperature of a substance rises, its density decreases and volume increases. Water is an exception to this rule. As the temperature of water rises above 0 degrees Celsius up to 4 degrees Celsius, its density increases. It is maximum at 4 degrees Celsius. After that, like other liquids, its density decreases with rising temperature. Means, as the temperature of water rises above 4 degrees Celsius, its density decreases. This property of water is called the anomalous expansion of water. What effects do we see in this anomalous behavior? The surface layer of water in a reservoir freezes at 0 degrees Celsius, but the temperature of the water below the surface is 4 degrees Celsius, so it has a greater density. Hence, that water stays down and the aquatic animals in the reservoir can survive in the water. Let us now learn about salinity of water. As water flows, salts from the soil dissolve in it. Rivers, streams, rivulets all flow into the sea. Hence, the water of the sea becomes salty. Thus, the quantity of salts in the sea goes on increasing. At the same time, water in the sea is continuously evaporating. This results in increased concentration of salt in the water. It is about 35 grams per liter. Hence, the density of seawater is more than that of ordinary water. That makes it easier to swim in seawater. Have you heard about the Dead Sea? The sea on the borders of Israel and Jordan, that is in the Middle East, is called the Dead Sea. Actually, it can be said to be a 60-kilometer long, 20-kilometer wide lake. The river Jordan flows into it. Other small streams, brooks, also flow into it. The level of this sea is as much as 396 meter below sea level, and there is no outlet for the water. Besides, the temperature causes the water to evaporate all the time. For this reason, the water in this area contains 23% to 25% salts. In other seas, this proportion is 3.5% to 4%. The salts in the Dead Sea water are mainly potassium and magnesium chloride and calcium chloride and bromide. No aquatic life can survive in this saline water. That is why it is called the Dead Sea. Naturally, with so much salt content, the density of the water of the Dead Sea is much greater than normal water, and there is no danger of drowning in it. Children, now let us see what is meant by limsoll line. To indicate how much a ship can be loaded, a line is marked on the ship's side, especially on cargo ships which carry goods. It is called the limsoll line. In olden times, to make the maximum possible profit, a ship would be loaded excessively. A ship loaded like this was in greater danger of sinking. By the efforts of a British politician, Samuel Plimsoll, a law was enacted in 1876 which made it mandatory to mark such a line on every ship. Legally, a ship may be loaded only till the limsoll line is visible above the level of the sea. Let us come to the last part of the chapter, that is, solubility of water. What happens when we add sugar to water and stir it? Small particles of sugar spread out in the water. Gradually, they become smaller and smaller and disappear completely in the water. We say that the sugar has dissolved in the water. The substance that dissolves is called the solute. In the above example, the sugar is solute. The substance in which the solute dissolves is called the solvent. Water is a solvent in the above example. When the solute and solvent are completely mixed in each other, we get a solution. In the above example, the sweet water is the solution. Water is called the universal solvent because many substances dissolve in it. Chemically, water is a neutral substance. This property makes water an ideal medium for most chemical reactions.